let's go over them. X squared plus x. What do these two terms have in common? An x. So I'm going to factor out or reverse distribute an x. Okay, so I'm going to say x should be multiplied by what to make an x squared plus x? X plus 1, yeah. So x times what will give me x squared? X. And x times what will give me x? A 1. So you have x times x plus 1. So the directions factor, that means rewrite your expression as a multiplication problem. You want to rewrite it as something times something else. So we've got x squared plus x rewritten as x times x plus 1. All right, so for B, we have x squared plus 11x plus 24. It's a trinomial, so it's going to factor to the double bubble. Okay, so I've got the double bubble here. I need to come up with two things, two binomials, that when I multiply them together, I get x squared plus 11x plus 24. So when you multiply two binomials, we use that little tool called FOIL. You multiply first, outer, inner, last, right? So if my first two, when I multiply them together, I need to get an x squared. What should my firsts be? X and x, yep. Okay, and my lasts, when I multiply those two together, should give me 24. So I have several possibilities. What could I use? 12 and 2, 8 and 3, 1 and 24, 6 and 4. Okay, so I have several possibilities. You can just try each one, multiply them together, and see which one gives you x squared plus 11x plus 24. Or we could try to think it through before multiplying, before writing it down. So somebody tell me which one you used and how you knew how to use it. Go ahead. Yes. 8 and 3. So you choose the two numbers that are going to multiply to 24 and add to this middle coefficient. So we use 8 and 3. So that way, when you multiply these back together, by using FOIL, you get the original thing. So we're going to have x squared for the first. The outer terms multiply to 3x. The inner terms multiply to 8x. And the last is 24. So the 3x and the 8x make the 11x. Okay, so it's a little harder if the coefficient on x squared isn't a 1. It's a little harder to figure out whether we should have used 3 and 8 or 6 and 4 or 12 and 2. There's a little more guess and check. You have to just try them and see which one works. All right, how about x squared minus 49? Anyone remember how to factor this? Yeah. Great. So this is the difference of two perfect squares, right? X squared is a square and 49 is the square of 7. So when you have difference of squares, it always factors to x minus the square root times x plus the square root of the number. All right, and so for D, if you haven't finished it yet, I'm going to give you a little hint, and I'll give you like 1 more minute to think about it. My hint is pick some new number, like y, and let it equal z plus 2. Go through your equation, replace your z plus 2's with y's, and then see if you can finish from there. Okay, so the reason I did this little trick is because I had two z plus 2 terms, right? Z plus 2 showed up twice. So I said, I'm just going to make this look a little simpler, right? Because that's what mathematicians do. They try to make it look easier. Turn it into a problem you know how to do. So we have y squared minus 5y. Now this looks really similar to A, the first problem that we solved, because there's a y in both terms. So I'm going to reverse distribute that y, and what I get in parentheses would be y minus 5. Then you go back and replace your y's with z plus 2's. So instead of a y, I have a z plus 2. And instead of y minus 5, I have z plus 2 minus 5, which is z minus 3. Yep, so we have z plus 2 times z minus 3. Now that is not the only way to solve this problem. I saw several other people doing it a different way, which is totally okay. I just wanted to show you this new little trick. Okay, so the purpose of reviewing factoring is that we're going to use this as a technique in solving equations, a quadratic equation. So the connection between solving a quadratic equation and factoring an expression lies in this really special property of the number 0 called the zero product property. It says that if you are multiplying two things together and the answer is 0, one of your factors, one of the things you're multiplying has to be 0. That's the only way to get 0 as the answer to a multiplication problem, is if one of the things you're multiplying together is 0. So that means that if you can factor a quadratic, then we know, and have one side be 0, then we can solve it by saying, well, either one factor or the other is 0. So for each of these, we already factored the left side in the previous example. So x squared plus x, we said that factors to x times x plus 1. Now, if I'm multiplying them together and the answer is 0, either x has to be 0 or x plus 1 has to be 0. That's the only way to get 0 as the answer to a multiplication problem. And then you solve each of these much simpler equations. Right? That one's solved. And this one, you get x equals -1. Here, this one factored to x plus 3 times x plus 8. And so we have two things being multiplied together. The answer is 0. So one or the other factor has to be 0. And we get x equals -3 or x equals -8. Oops, -3. And x squared minus 49 factors to x plus 7, x minus 7. Set each factor equal to 0. And solve each one separately. So we get x is -7 or x is 7. And then this one, we decided it factored to what? Z plus 2 times z minus 3. So set z plus 2 equal to 0 and z minus 3 equal to 0. And we get z is -2 or z is 3. Comfortable? Okay. So keep in mind, though, factoring one side of the equation is only useful if the other side is already 0, right? It only helps if you have the right side or one of the sides is 0. So before you start factoring, make sure one side of your equation is 0. Move everything to one side. There's a third method for solving quadratic equations. It's generally the most useful because you can use it anytime, even if the quadratic doesn't factor. And it is called the quadratic formula. So if you can put the equation into that form, ax squared plus bx plus c, A is the coefficient on x squared, B is the coefficient on x, and C is the constant. Then the quadratic formula says you can calculate x by using this formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You'll probably memorize this because you'll use it so frequently in the class. But keep in mind, on quizzes, you're allowed to bring a note card, 3x5 note card, and to tests, you can bring a piece of paper with notes on it. So this is something you should always have written down with you if you have trouble memorizing things. Okay? But you will use it a lot. And there's a little musical way to remember it also. Who knows it? Can you sing it for us? Yeah. Oh, that's great. That's a different one. That's not the one that I use. But that's a good one. Mine is To Pop Goes the Weasel. All right, I'm going to sing it. Everybody please reserve judgment. Okay, it goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's just a little device to help you memorize it. Oh, and I just recorded it. Oh. All right, so we're going to solve these with the quadratic formula. I'm going to do one with you, and then I'll have you work on a few in your groups. So the first thing we do is identify A, B, and C. So here in A, question A, what is A? 1. The coefficient on the x squared is a 1. And what is B? Negative 6. And C is negative 7. Now we can just take those numbers and plug them into the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, good. So now you just replace the numbers in the formula with the numbers that you've written down here. So I'm going to replace this is negative b. You can also read this as the opposite of b. So if b is already negative, you make it positive. So this is the opposite of b. B is negative 6, so this becomes 6 plus or minus the square root of b squared. So negative 6 squared is 36 minus 4 times a times c all over 2 times a. So this is 6 plus or minus the square root of 36. And then I have a minus sign here and a minus sign here. Negative times a negative should give me a positive. 28. 4 times 1 times 7. All over 2. And so this is going to be 6 plus or minus 36, 46, 56, 64. Square root of 64 all over 2. Square root of 64 is 8. So this is 6 plus or minus 8 over 2. And then you just, this is plus or minus. So this is really two expressions written combined as one. So you do 6 plus 8 over 2. That would be 14 over 2, which is 7. Or 6 minus 8 over 2. 6 minus 8 is negative 2. Divided by 2 is negative 1. So we get 7 or negative 1. All right, I want you to try the next one on your own. Discuss with your group if you get stuck. Keep in mind, you want to have everything on one side. You want to have one side be 0 before you start using the quadratic formula. So remember, you can't use the quadratic formula until one side of your equation is 0. So I'm going to move everything over to the left side by subtracting 20x and adding 6 to both sides. So I get 5x squared minus 20x plus 6 equals 0. Now, A is 5, B is negative 20, and C is 6. So we have x equals negative b, so that would be positive 20, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. All right, so x is 20 plus or minus the square root of 400 minus 120. And 400 minus 120 is 280. All over 10. Now, I am not a stickler about simplifying. Some teachers are. It all depends on what you're trying to do, right? So I mean, how much simpler is it really if we pull out a 4 from that radical 280? We could. So I would accept this as an answer, perfectly fine. So would WebAssign. WebAssign accepts these things unsimplified as long as it's correct. If you want to simplify it, you rewrite what's under the square root as a product of a perfect square and something else, right? The largest perfect square that goes into 280 would be what? 4, yep. So this would be 4 times 70 all over 10. And then the whole purpose of doing that is that now you have a perfect square under the square root, so you can square root it and take it out. So this would be 20 plus or minus 2 square roots of 70 all over 10. And then you can reduce the fraction, right? You can say, well, 2 goes into 20 10 times, goes into 2 once, and it goes into 10 5 times. So this would be ultimately simplified to 10 plus or minus the square root of 70 all over 5.
10 over 5 plus or minus root of 70.
That's the same thing.
Okay.
Yep. Good. That would be totally acceptable. Yeah. So again, the simplification is, this is something that you learn in a previous course. It's not the focus of what I'm trying to teach you right now. I'm trying to teach you how to solve a quadratic equation. So it is important that you be able to recognize that what you got here and what's written as the answer in the back of a book or on the next page of my notes, it's important that you be able to recognize that they're the same thing. But if you leave something unsimplified on a test, it's not a big deal. Okay? Okay. Raise your hand if you have not finished these two. All right, handful of people. So take 5 minutes and work through what you still have left, and then we will do the last little bit after that. So you have the answers to these guys. So I want to point out that we got several different kinds of answers here, right? So with A, we got 2 nice, pretty answers, right? Just nice integers, -1 and 7. I love those guys, right? And with B, everybody was like, I got 2 answers again, and it was like, ew, oh, those are awful, right? The square root of 280, square root of 70. I don't like those guys. Okay, I have 2 ugly answers. With C, you just come up with 1 answer. How come that happened? Why is there only 1? The part under the square root was 0. Yeah, good. And For D, you ended up with a negative under the square root, which right now we don't know what that means, right? It doesn't mean anything. It doesn't exist. So we have non-real answers because we have a square root under the negative. So I'm just going to jump over the following object problem for 1 second. And this part where I have you read and complete for homework. You just have to read this. So these are the different kinds of answers you can get. You can get 2 rational answers, which are those nice, friendly, lovable numbers. Like in part A, you can get 1 rational number. You can get 2 irrational numbers. That's when you're left with a square root that you can't reduce. Or you could get 2 non-real answers. And it all depends on what happens under the radical. That's the only thing that indicates what kind of answers you're going to get. If that thing under the radical, the b squared minus 4ac, if it's positive and a perfect square, that's when you get the nice friendly numbers. That's when you get 2 rational solutions. And if the number under the square root is positive, but it's not a perfect square, that's when you get the 2 ugly answers, 2 irrational solutions. If b squared minus 4ac is 0, the number under the radical is 0, you get 1 rational solution, 1 nice friendly number. And if the number under the square root comes out negative, you end up with 2 non-real solutions. So now you don't have to do this for homework. We just discussed it. All right, so we'll just go back to the falling body problem. That's the last thing we got to do. So if we have an object dropped from a height of h naught, so that little 0, the subscript 0, is verbalized. We say that as h naught, right? Not as in like it was all for naught, nothing, right? To mean 0, h naught. Okay, so that's our initial height above the ground. Then the height of the object after t seconds is given by this formula. So the negative 16t squared, that has to do, this formula comes from things that we know about physics and the acceleration of gravity. So this is the formula for the height of the ball after you drop it. How long will it take for the ball to hit the ground if we drop it from 96 feet off the ground to the top of this building? So which variable should I replace with 96? h0, you got it. Yeah, that is the initial height you drop from. So I have h equals negative 16t squared plus 96. Okay. Now, how long will it take for that ball to hit the ground? So the question is how long, right? So which variable do you think we're going to be solving for, t or h? T, right? Because how long is a time kind of question. So that means I must know h, right? What is h? 0, because when you hit the ground, you are 0 feet off the ground. Great. So how do you want to solve this equation? Minus, yeah. That's okay. Divide by negative 16. So we end up with t squared equals 6. So t is square root of 6. Why aren't I writing plus or minus? Because you don't go backwards in time. Good. And the square root of 6, you could type in your calculator, and it's approximately what? 2.44 seconds. So it would take almost 2.5 seconds for the ball to hit the ground. How long will it take the ball to get halfway to the ground? 1.22 seconds? No, it would not. So halfway to the ground, that would be 48 feet. So I'll replace h with a 48. We could solve this one similarly. Subtract 96 from both sides. Right, we're still dropping it from 96 feet off the ground. H naught stays the same. That's the height you drop it from. And we want to know how long until it gets down to 48 feet off the ground. So divide both sides by negative 16. And we get t squared equals 3. So t is the square root of 3, which is approximately what? 1.5? Oh, I don't know. Oh, no, half of 3 and the square root of 3 are two different things. 1.73, thank you. 1.73 seconds. Why isn't it half the time? Why isn't it 1.22 seconds, half the time it takes to get to the ground? Because of the acceleration of gravity. It doesn't fall at a constant speed. It's falling faster and faster and faster. Yeah. Right, until you reach terminal velocity, but you have to jump like, you'd have to drop it from really high to reach terminal velocity. All right, so we don't really have, oh, well, we do have 7 or 8 minutes. You can start working on this worksheet for a little extra practice, and then we have some learning objectives, and your homework is in WebAssign.